In this lesson, I'm going to be discussing simplifying radicals. And when we're simplifying radicals, that means we're not approximating with a decimal. We're finding an exact value. We just want to fully simplify it, which means we're going to remove any perfect square factors. The only time something comes out from underneath the radical sign is if it's a perfect square. So we need to find a way to look at numbers and see if they have any perfect square factors. Before we get started, there's one property I want to talk about that we'll use in this lesson, and that is if I have the square root of a product of numbers, say a times b, I can split that radical up and write it as a product of two radicals, square root of a times the square root of b. And this is going to be a useful property. The method I'm going to use to find perfect square factors is called a prime factor tree. And as you get better at simplifying radicals, you may not need the factor tree, but if you're struggling or having a hard time or don't really know what you're doing yet, it's a good way to get started. So let's jump in and try an example. Start with the square root of 32. If I want to simplify the square root of 32, I want to look for perfect square factors. So I'm going to do a prime factor tree. Put my side work over here. And my side work is going to be that factor tree. With a factor tree, it doesn't matter how I start. I could do 2 times 16, I could do 4 times 8, but I should end up with the same result in the end. So I'll start with 4 times 8. And when you complete the factor tree, you should get down to all prime numbers. So 32 is equal to 2 times 2 times 2 times 2 times 2. So I'm going to come back over here to my radical, and I'm going to reorganize it. I'm going to reorganize it into pairs and non-pairs. The first radical is going to be all the pairs. The second radical is going to be everything that's left over. So if I look at my 4 2's, my 5 2's, I'm sorry, I want to take and have 2 radicals, and the first radical is going to go all the pairs. Well, I've got 5 2's, so that means 4 of them make up pairs. I've got 2 pairs of 2's. All those go into the first radical. And the reason, if I have a pair of numbers like 2 times 2, that means it has to be a perfect square. So if you ever have an even amount of a number, that means it's going to make a perfect square. And here, when I split this up in 2 radicals, I was just using this property that I talked about up here. 2 times 2 times 2 times 2 is 16. And there's only one number over there, so I just rewrite it. Now, if you've done this correctly and you've organized into pairs and non-pairs, it'll work out very nicely because the first radical will always be a perfect square, and the second radical will always be fully simplified, meaning there are no pairs in it, so there's no perfect square factors in it. Square root of 16 is 4 times the square root of 2. And that's the answer. So that's the process we're going to be doing. And if you follow that process, you'll usually have some success. Let's try another one. Square root of 40. So again, I'm going to do my prime factor tree over here on the side. Take 40. Say 4 times 10, 2 times 2, and 2 times 5. So I've gotten to a point where I have all prime numbers. 40 is equal to 2 times 2 times 2 times 5. Now you should always check, do I have any pairs? If you don't have any pairs, that means your radical can't be simplified at all. If your number is all pairs, that means it has to be a perfect square. This number has some pairs, but it's not all pairs. So let's go ahead and come back over by the radical and rewrite it. It's equal to 2 times 2 times 2 times 5. Now I want to split this up into 2 radicals. Under the first radical goes all my pairs. Under the second radical goes what's left over. So I have a pair of 2's, and then I have a 2 and a 5 that aren't a part of a pair. Again, this first radical will always be a perfect square, and the second radical will always be simplified, because each number appears only once. Square root of 4 is 2, and then just rewrite the square root of 10. Try another one. The square root of 108. Again, do my factor tree. You want to keep organized when you do your factor tree. Make sure you don't miss any numbers. I'm using the highlighter. You don't have to do that, but you might want to go through and make sure you don't, make sure you don't leave any numbers out. So I've got So I've got 2 times 2 times 3 times 3 times 3. 1, 2, 3, 4, 5 numbers. So I'll come back over here and I'm going to rewrite my radical. 2 times 2 times 3 times 3 times 3. And I'm going to break that up into pairs and non-pairs. 2 times 2 times 3 times 3. A pair of 2's and a pair of 3's. And what's left over? Just 1 3. These numbers come out to be 36. That's just the square root of 3. Again, the square root of 36 is a perfect square, 6. So your answer is 6 times the square root of 3. Or it's radical, so sometimes we say 6 rad 3. All right, and as you get better at this, again, you may not need the tree, but it's always a good skill to have. As numbers get larger, you may want to revert back to using the tree. A mistake that I see a lot is someone will see the square root of 80, and they are confident they won't use a tree, and they'll say, okay, that's the square root of 4 times the square root of 20, because they know 4 is a perfect square. And they get 2 times the square root of 20, and they leave that as their answer. That's not correct, because the square root of 20 still has a perfect square factor in it. So, again, a good way to do it is to do the factor tree. And you could still get the right answer from that by saying, taking out another square root of 4. But it might have been easier if I had just done the factor tree and found that, and found the largest perfect square factor from the beginning. So 80 is equal to 2 times 2 times 2 times 2 times 5. So if I'd done it over here, I might have said the square root of 2 times 2 times 2 times 2 and the square root of 5, which would give me the square root of 16 times the square root of 5, which gives me 4 times the square root of 5. Same answer. Okay. And you will come out with the same answer. Just be careful if you're not going to do the factor tree to take out all the perfect square factors. Try an example of a number that works out a little bit differently. Let's say we have the square root of 30. If I do the factor tree on 30, 3 and 10, 2 and 5. So 30 is equal to 2 times 3 times 5. Well, if I organize that into pairs and non-pairs, what happens? I've got no pairs. So what does that mean? That means that there are no perfect square factors in the square root of 30, and that would be your answer. That's example 6. Let's try the square root of 324. Square root of 324. Do my factor tree. 2 and 162, 2 and 81, 9 and 9, 3, 3, 3 and 3. 324 is equal to 2 times 2 times 3 times 3 times 3 times 3. So if we were asked to organize that one into pairs and non-pairs, it would be all pairs. Well, what does that tell us? That tells us that this number is a perfect square. And the square root of 324 is in fact 18. So this should give you a basic idea on how to simplify radicals when you have just one number under the radical and you want to simplify it. Again, you draw a prime factor tree, you organize into pairs and non-pairs. Remember this method as we move into more complex radical problems.